Okay, so we're going to do a continuation from what we did on Thursday. We're starting to do the example is called perfect game. And basically what happens is the pitcher doesn't allow any hitters to reach base in all 9 innings. Okay? So, historically, let's see here. Let's see here. 40% of, let's see here, 40%. Oh, 40% of the time we get a perfect inning. Okay? Just an inning, not the game, the inning. Okay, so that happens 40% of the time. So now we're going to calculate. So what is the probability of throwing a perfect game? Yep, I'll get to you in just a second. We're talking perfect game. Okay? Okay. So we'll stop there for a second. Okay, so we're going to say so what is the probability of throwing a perfect game? We need to assume one characteristic though, okay? We're going to assume that each inning pitched is independent of the other innings. Okay, and I realize that that's a big assumption because usually you start getting nervous, you're getting tired, and so that's it's not always going to happen. Okay, so basically what happens is if you've got 9 innings, correct? So if we got 1, 2, 3, 9 innings, all the way up to 9. Okay, now what's the probability of pitching a perfect inning here? 40%. So we're just going to put a 0.40 there. And each inning after that is also going to be 40%. Okay? And the reason why it's 40% is we're saying that they're independent, that this outcome doesn't depend on this outcome. Okay? Kind of does, but we're going to let it go. All right? So each inning is going to be independent. So then that means if we use our algebra skills, what's my power going to be? And you would say to the 9th power because there are 9 innings pitched. Okay, so then if I just use my calculator real quick, oops, 0.40 raised to the 9th power, I get well, mine doesn't. I just got to remember. So what I do is when I see that e to the -4, okay? So what I do is I go, okay, that means I'm going to have 0, and then I'm going to have 3 zeros after it. See how there's a total of 4 zeros? That tells me how many zeros I have before my next number. So then that would be the 2. Yes, sir. You can do e to the -4. You can do that. That's fine too. But when I change this into percents, that's your percent. Okay? That's how likely you are to pitch a game. So not even a full percent. Okay? Now, here's what we're going to do. This is to pitch one perfect game, correct? And this is when you go yes. Okay. So how many games are there normally in a normal season? Not even close, you foolish boy. So there's 162 games, and then there are 30 Major League Baseball teams, okay? So if we take this answer here, we times it by 162, we times it by how many teams there are, we expect to see we expect to see 1.27 perfect games a season. Okay? Now, is there anybody a baseball fan? We know it's not Perry. Okay? So typically, we only see a perfect game about one game every 4 to 5 seasons. Yeah, definitely. I don't know. I have to go look that one up. That'd be something interesting to hear. See someone's actually pitched to in their careers. Yeah. So it's pretty much zero to pitch a perfect game, and then to pitch two of them. Yeah, it's not. So I guess what you could do is you could sit there and say, okay, if I know a pitcher's pitched, and then you got to think about he's got to pitch 9 perfect innings. So okay, so we're doing our last example. It's called the first trimester screen. Basically, what happens is that there's a non-invasive test that is to determine if there's anything abnormal with the chromosomes of a fetus. And then, according to a study in the New England Journal of Medicine, 5% of normal pregnancies will receive a positive result, so that's a false positive. So if we have 1,000 women with normal pregnancies are tested with the first trimester screen, what's the probability that at least one woman will receive a positive result? Okay, so what we want to think about is we got a probability at least, I don't know why I crossed my L, but anyway, at least one positive result. Now this is the part we got to be careful about, okay? I don't say careful, but what we're actually counting, okay? So if we want one positive result, right? Think about this. So I'll just simplify it down there. So if I said to you, we're flipping 3 coins, okay? And I want at least one head, right? At least one head. That means I could have a head, tail, tail, right? I could have a tail, head, tail. I could also have a tail, tail, head. I could also have a head, head, tail, head, and a tail, head, head, and a head, head, head. All those, right? At least one. That means I only want at least one. All right. Now, going back to 5-2, if we were to use the complement rule, right, what could we do? So if you think about it, I want, how about if I said no results, no positive results? Okay. So that means I'm going to have negative, 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 all the way for that 1,000, right? And but the one right after that is going to be positive, then all those negatives, right? Positive, all those negatives, positive, all those negatives. So then what we can sit there and say is then I'm going to use the complement rule to make my life easier, okay? So I'm going to go with 1 minus the probability of no positive results. All right, so then this is where we're going to come into here, and we're going to put our 0.05, okay? Then that way, we're going to come in here and say 0.95, okay? And then what we're going to do is we're going to take the 0.95, and how many times are we doing this? 1,000 times. So we're going to raise it to point. I hope my calculator can handle this. I'd go like that if I were you. Yep. Yeah. Okay. All right. So now, if we did, let's see here. We want, how can I put this? Okay. So this is all 1,000 are negative. Is that on the screen? Okay. So all 1,000 are negative. All right. So what happens if I want at least one? Well, if I go like this and redo the subtracting again, okay, then, oh, this is going to be redonkulous. It's just so small that I'm going to leave it like that. Okay. Because if you do 1 minus this, guess what the calculator is going to give you? Nope, it's going to give you 1. So that's saying that 100% means that you're going to get at least one positive result. Okay, you're going to get one. There is a 99.99 probability that at least one of the 1,000 women will receive a false positive. And then once you do that test, and they do other tests and make sure that the baby's actually fine or what they need to do. Okay? So don't forget to use your complement rule. When it says at least one positive, that means you're going to want to do the complement rule. Guaranteed. Okay? Okay. Let me pause. So there is our homework for the section, and then bring some questions in. We can go from there.